In this video, we will relate the idea of times as large as comparisons and percent comparisons. So let's get started. Here I have two segments, one representing the value of A, and A is equal to 9, and then another segment representing the value of B, where B is equal to 5. So start by measuring A in units of B. So if we visually look at this, A is a little less than 2 times as long as B, so the measure of A in units of B is a little less than 2. But we can actually be more precise since we know the values of A and B. So the measure of A in units of B is represented as A divided by B, which is equal to 9 divided by 5, which is equal to 1.8. So if we measure A using B, we get a measurement of 1.8. So we could say that A is 1.8 times as large as, I'm going to abbreviate this, times as large as B. Now let's measure A using 1/100th of B. So 1/100th of B is like a little portion of B, and it's just 1/100th of that entire segment. So I'll represent that there, although that's probably not proportionally correct. But if we measure A using B, we get a measurement of 1.8. If we measure A using something that's 1/100th times as large, the measurement itself should be 100 times as large. So the measure of A using 1/100th of B should be 100 times as large as this measurement. So the measurement of A using 1/100th of B should be 100 times the measure of A using B. And 100 times 1.8 is equal to 180. So if we measure A in units of 1/100th of B, we get a measurement of 180. Now this 1/100th of B, this piece right here, we refer to 1/100th of B as 1% of B. So 1/100th of B, we just call that 1% of B. And therefore, if we measure A in units of 1% of B, we get a measurement of 180, and therefore we would say that A is 180% of B. So this idea of percent is very related to idea of times as large as. So in this case, A is 1.8 times as large as B. We say A is 180% of B. Let's look at an applied example. So suppose CJ's annual salary increased from $40,000 to $50,000. Let's start by doing a times as large as comparison. So if we do his new salary, $50,000, divided by his initial salary, $40,000, we get a value of 1.25, which tells us his new salary is 1.25 times as large as his original salary. Now, if we want to do a percent of comparison, then we would measure his new salary in units of 1% of his original salary. And 1% of his original salary is 1/100th of 40,000. So we measure this same 50,000 in units of something that's 1/100th times as large. Our measurement should be 100 times as large. So the measure of 50,000 in units of 1% of 40,000 should be 100 times as large as 1.25, which is equal to 125. So his new salary, I'll just write this as new. So his new salary is 125% of his original salary.